Okay, hello everybody, welcome to today's session, which is part 2 of building a full stack application from scratch. This is a continuation of part 1, since by part 1 we finished what would be our backend, Node.js code, and now it is time for testing. So testing is something that gives a lot of people trouble, that gave me trouble, to be honest. I didn't really like testing, and I don't think many people like testing when they first learn about it. It's kind of tedious, but once you join a real-world project and you start seeing people introduce bugs into super large web applications, and then you're the one that has to fix them, you start to value testing more, because testing just helps there be less bugs. So let's get started. Now, so this is just the same project we built last time. However, it still has no tests. So that's what we're going to proceed to add today. So before we can begin testing, we need a few dependencies for testing. So let's install them right now. So let's open our terminal and let's install a few dependencies. So I'm going to install, let's say chai. I'm going to save chai HTTP. That's what we use to test our Express server. Maca is our test engine, super important. That's what allows us to actually run our tests. We will also use Faker. Faker is really good. We can use Faker to simulate fake data, and I believe that's it. So let me just quickly verify something going on. Oh yeah, that's working. Cool. So that's pretty much it. Let's have that install while we create our test folder. So all our tests are going to be saved into this heavy test folder. So inside of test, it's going to be our home folder for test. And our first test is going to be, how about we test our server? So let's do server.test.js. And right now it doesn't really have anything. So let's include our basic boilerplate. So we're, of course, because this file gets run by Maca. Remember, Maca is our test runner. Basically, you need to load chai, which is the assertion library. So chai is what helps you do the actual testing, like check if variable A is true, check if variable C is false, stuff like that. And then chai HTTP is something we use to actually test Express apps. Now, we cannot test if we don't also import some useful things to test. So in this case, we're going to import our server. So our server is located in app/server.js, as you can see right here. And I'm also importing the start and stop server methods, because you will see why they're very important very soon enough. So let me include all of this, and let's have our first test included like so. So this is what our first test looks like. So notice how we use these functions called before and after. Now, this is what we call a Maca Hook. So Maca has a really nice feature called hooks, which basically are utility functions that can be run on a specific point in time while your tests are running. So for example, before runs this actual function before all your tests. So if I had 3 it blocks here, 3 it tests inside of here, it would run my before function one time before all the it blocks at this level. Then my after function will be running this function one time after all my it blocks get executed. So that's pretty much it as far as how Maca hooks work. Now, these two functions are extremely important, because what I'm doing here essentially is I'm starting my server before all the tests, because otherwise, if these tests try to test the server and it's not live yet, it's going to crash. So that's one. We have to start the server before all our tests, and after we run all our tests on this file, we make sure we stop our server. That's also very important. So having said that, we have our first test right here. So our first test, thankfully, is very straightforward. So it just says should return index.html. Now, this is a new test I added since last time. In order for this to work, I need to add just one HTML page in public, so this can pass. So I'm going to add index.html, and inside of it, I'm going to add a basic HTML template. There we go. And let's just leave it like so. So it's just a simple page, so that this test can pass. And all we're doing is we're using Chai's HTTP request plugin. So the reason why you can know that we're using Chai HTTP plugin is because we imported it right here. So that is what allows us to basically test against Chai HTTP. However, we're missing two very important details here. So notice how it's throwing an error saying expect is not defined. So that is because I forgot to do two very, very important things before my test. So what I do is I like to extract the expect variable from Chai into a new variable. Otherwise, I would have to type chai.expect something, chai.expect something else. And that's just really tiresome to write out. It's kind of redundant, so I just extract it into its own variable. And then this is what allows us to do chai.request. So Chai uses a plugin called Chai HTTP, which enables Chai to actually test against HTTP Express apps. So using this, we can do chai.request, then we inject or express application. So this app right here is actually exported by our server. So as you can see, this is our server.js file. And you can see, if I put them side by side, so I am importing it from my server.js file, and here I am exporting it. And basically app is just when my Express application once I created it, as you can see right here. So we're going to use our Express app to make a direct request to the slash URL. And then if that's successful, we add a response and we expect the response to have many things, like to have status of OK. Notice how I'm using this really handy HTTP status codes. So it's something I also exported to make it easier for me to test. So here's my status codes. I have all of them named, so it's easier and just better visually. Instead of typing out a number, I can just type it as a word. So I'm checking that this has to have a status code of OK. I also make sure that this is of type HTML, and I also check the responses text to have a string of doc type HTML. So that's pretty much it as far as this test goes. If you're curious, which like me, when I first started out testing, kind of a pain point for me was remembering all the types of assertions you can make. So you can always check the documentation for questions like this. So if we, for example, follow that link that I added on the comment, you can go to the official Chai HTTP plugin documentation that teaches you about all the tests you can do, like expect response to have a status of 200, or expect request to have a header of something, or expect to be a JSON, HTML, text, the usual. So be sure to check out documentation. It's your best friend when it comes to questions about what you can use to test your functions. So going back to this, I think it is time to test this, to actually run it. So we could test this using Maca. However, in order to test it, we need to remember, like we did last time, we need to be able to run these via our npm scripts. So let us modify or test script. So let's delete everything inside of it because we don't really need this anymore. And let's type Maca. So by typing Maca, basically it's going to load our Maca installation. This is from inside our Node modules folder, as you can see right here. So our Node modules folder is what includes all the dependencies of our project that we installed. So it installs Maca, it loads it, and it runs all the tests inside of the test folder automatically. So let's try that. Let's toggle our terminal and let's type npm test. And let's see if that runs our tests. And let's hope for the best that it runs. There we go. It's running and it succeeds as expected. Now, I'm also going to teach you really quickly how to debug tests, because that is also a very, very common pain point of, I think, everybody in general. Like debugging already is kind of challenging, but debugging tests can be quite a bit more daunting. So if you remember part 1, we already made a basic debug configuration to debug our server.js. So you access the debug configuration by clicking on the gear icon. And this is what we have right now, or so far. So we have a debugger configuration that launches start.js that's located inside of our workspace folder. So it's this start.js. So in order to test Maca, it's going to be a bit harder because we don't really run server.test.js. We actually run the Maca file, the Maca executable. So to make our life easier, because this is something that's been done dozens of times, I'm going to just search for VS Code Maca debugging. And the great folks at VS Code Recipes from Microsoft, they created already debugger configurations for Maca unit testing to make it much easier for you to use. So I'm just going to copy over their 2 configuration objects. I'm going to copy this and paste it right here. So we now have 2 new objects that look a bit complex, but bear with me. So basically, instead of running our server.test.js file, it runs the actual Maca installation in our Node modules folder. It also adds some useful things like colors. It adds a timeout so that even if we debug for a long time, it doesn't crash on us. And finally, it tells it where to run the tests. So we have 2 default very nice configurations called Maca all and Maca current file. So it's self-explanatory. This one runs all the Maca tests in our project, and this one just runs that specific test you have opened at the moment. So let's test it out by switching our debugger configuration from debug server to Maca all. Notice how it uses the names we gave them, so it's really handy. And let's click on play and see what happens. So I'm clicking on play. It should start a new debugger configuration instance. And let's see, there we go. Debugger attached, seems like we're good. Let's monitor, there we go. That ran as expected. So it ran all our tests and then it exited. So that's good. We can now run tests from VS Code. Now, that isn't very useful unless we can actually stop the code. So let me show you how to do that right now. So to stop the code in a test, you can do it one of 2 ways. One, using these red dots that always appear next to the line number. So I can add a few red dots and it will stop every time it reaches a red dot. So I'm going to press play, and this time it should stop once it reaches line 35. Let's wait and see. And there we go. It stops on line 35, and that allows us to do many things, like we can see what's inside of each variable, we can explore the entire response object, we can see if the test is actually valid, or if it crashes, why it crashes, we can identify variables, or we can even use the actual debug console to enter JavaScript, as we saw last session. So we can type actual JavaScript here, like var x equals 1, and return x plus 5, or var y equals x plus 5, or we can actually input actual JavaScript variables to see them evaluated here. So as you can see, I copy pasted response here, and I can see the contents of response and even access its properties like response.text and see what's inside of it, as you can see right here. So this is an insanely powerful tool to help you just have a better grasp of what you can actually do, why your tests are running, why they're not running. And as usual, you can use the debugger controls to, for example, this one runs your code line by line. So you can just inspect if everything works as expected, or you can press the play button, and this will let your code run until it finds another debugger breakpoint. And that's method number 1. Method number 2 is something I tend to prefer in some situations, which is just writing the word debugger. Literally, writing the word debugger forces your debugger to stop if it is running your code. So just by tapping that word out, you will see that my code will also stop, as shown. Come on. Here, there we go. So that stops. And that's pretty much enough as far as demo goes. So let's move on to our first actual test, something more useful. So I really like to begin testing something like authentication or users. So let's begin with auth, because that's easily the hardest thing to test. And once we get that done, everything else just kind of falls into place. It's kind of a cakewalk. So let's add our authentication.test.js file. Now, this file is going to be as well pretty much empty at first. So this time we're going to import a few NPM libraries we installed. So we're going to import Mongoose for basically reaching out to our MongoDB database. We're going to be using Chai for the actual testing, ChaiGDP to connect to Express, JSON Web Token to simulate JSON Web Tokens. You'll see very soon why. And Faker is a pretty cool library, to be honest. I'll be frank with you. It's an amazing library, Faker. I really like using Faker, and you will see very soon why. So let me add our first block. So let's add our first block right here. So here's our describe block. So it's going to be integration test for API/auth. So we're going to be testing app/auth/router. That's what we're going to be testing in this file. So in order to test this, there's a few things we first need to do. As usual, you need to, before and after, start and stop your Express server. So let me do that right now. And then also, because this time I'm actually testing against a database, because my server runs against a MongoDB database, I had to do two extra things. So before I can do that, I need to also, of course, import my start and stop server functions, and just add the usual boilerplate. So here is a few variables I import from my config file. I import a lot of server-side variables. I import my entire structure from my server.js. And I'm also, notice how I'm importing my user model. So the way that I can store users. You'll see very soon why. So because we're now running against the database, we need to, number one, delete our entire database every single time each test runs. So let's add that right now. So let's do after each. So this will run after each test block, and after each one, it's going to return a new promise, because otherwise Maca won't know if your code is done running. So I return a new promise, and inside of it, I delete the entire MongoDB database I'm running on. So this is super critical. You need to delete the entire database over each test run, and we do this because imagine having tests, and then imagine test A leaves some junk behind on the database which causes test B to crash. You do not want that. You want to be using a clean new database for each and every single test. So here we delete it after every single test. And we also add a new function called before each. And this one is going to be really interesting. So bear with me because it's going to look quite complex at first. So this before each function is going to have a very, very interesting piece of functionality or / feature. So basically, we are going to use this to populate this global here called test user. So what we're doing here essentially is we're going to create a new fake user, which will be done in a function you will see very soon. So we create a fake user object, and then we manually store the user into MongoDB your user model. So this user, if we look at where this came from, you see that it's from our actual MongoDB user. So we basically use our actual Mongoose model user to basically create an actual user into the database. And then with this created user, we extract the created user ID, save it into the created test user's ID parameter, and then we create a fake JSON Web Token. But fake is kind of debatable because it looks fake, but it's real. It's actually real. This is the same type of JSON Web Token your server uses to authenticate. So basically, we create a fake user before every single test block, and then we create a fake JSON Web Token as well before every single test block, which we will be using to test. So having said that, we need to take a quick peek at what our create faker user looks like. So let's add that function right here at the end. So it's a really nifty function that leverages our faker.js library, which we imported right here. So faker allows us to do something like name will be equals to a variable that has the faker.name.firstname and faker.name.lastname. Username will be faker.lorem.word, faker.random.number, and email. Faker even has a way of generating fake emails. So Faker is an amazing library. If you want to learn more, as usual, just literally search for it on NPM. That's the best way of finding what you need to basically use, or how you have to use a certain library. So if you search for Faker, you will see that they have a fantastic documentation of everything you can do with Faker. So they teach you a basic example of how to use Faker. They give you a lot of the things you can do with Faker, like you can generate fake address codes, fake commerce messages, fake things related to a company, fake dates, fake finance related things. It's just a ton of things. So yeah, that's Faker. And with this in mind, I think we're pretty much set in order to write our first test. So our first test is going to be for the login endpoint. We want to make sure we can actually log into our database. So let us do that right now. So in order to test login, we need to add a test for that. So let's add it. How about here? So this is our login test. Now, the way this works is this checks that you should log in correctly and return a valid JSON Web Token. So with this in mind, our test goes a bit like this. So in chai.req, we first make a request, a post type request. Notice how it has to match. So this .post matches our outrouters.post/login. So it makes a full request to API/auth/login. Reason why the API/auth is here is because in our server.js, notice how we are actually redirecting calls to /API/auth to our out router, which then chains that /login at the end. Now, with that said, at the end, it does a .send. So the .send, basically because we want to be able to log in, you have to send an actual username and password. But because before this test, it created a new fake user and the new fake JSON Web Token, we can actually try to log in with our newly created user, as we're doing here. And then I do some checks. Like I expect the response to have a status code of OK. I check that the response.body is an object. And most notably, I check that my body includes a JSON Web Token. To show you, I'm going to just super quickly run my test engine so we can stop the code and show you how basically the test is going to kind of flow. So let's run our debugger and let's wait and see for our actual code to stop there. So let's see. And you know what? I should have row 3T enabled because that would show you how our database looks. So let me open that in the background while our test engine is being set up. There we go. So there's our code stopped. In the meantime, I'm connecting to MongoDB. And I want to notice how I'm actually loading my fake test just jotted database. That is thanks to the way I wrote my server. So when I added my before start server function, I passed in a Boolean variable called true. So this enables my server that if it receives that variable as true, so we check here. So start server testemp, if testemp is true, use the test Mongo URL. So our test Mongo URL is in our config, and it's basically the same config we have, but instead of being named just jotted, it's named test just jotted. So with that, we can see that this should actually have our test fake user. So this is the fake user faker created for us. So it's Rosalina Mackenzie with an email of margaret.champlin@email.com and then a username of llegendi54. so that's kind of cool. And basically the test goes a bit like this. So we were left on expect response body to include a JSON Web Token. As you can see, it does include a JSON Web Token. Then if that passes, we basically use the JSON Web Token library plugin to verify that this JSON Web Token is in fact valid and it can be decrypted with the JWT secret. So this is something we can do thanks to us being the owners of this database. So once we do this, we're now able, if we're on this line, we're now able to extract the actual JSON Web Token payload. So we can extract everything from it and we can compare that the user matches the created user, and we compare the JSON Web Token user to the fake user we created, which as you can see, completely matches. So that should give us a successful test run. As you can see right here, both tests pass. Now, the next one is going to be very, very similar, to be honest. It's actually going to be nearly identical because the next endpoint we have to test is actually I believe the refresh endpoint. So it's this endpoint right here. So it's the refresh endpoint. So it does almost an identical piece of functionality. So the way it goes is it's also going to use the user we logged in. However, the difference here is because this one gets refreshed, we already have a JSON Web Token. So that is why we basically use the JSON Web Token we stored at the start. So we use this JSON Web Token we created at the start. Notice how the difference here is that the middleware, the login uses and accepts a username and password combination, but the refresh receives a JSON Web Token string that it then dumps and creates a new one for basically with a longer expiration date. So the way this gets tested is we make a request to API/auth/refresh. Then we set the actual JSON Web Token as a header. This is super important. Otherwise, we'll be thrown an error because we're unauthorized. And if that's successful, we can then basically do the same checks we did previously. We check that it does have a valid JSON Web Token. We check that the user in the JSON Web Token payload is the same user we created originally. But this is the last final check we do here. So this looks kind of weird, but it's actually simpler than it looks. So all we're doing here is the new JSON Web Token we create needs to have an expiration date that is later than the original JSON Web Token we created. So basically each JSON Web Token has an expiration date, and basically this allows us to verify that the new JSON Web Token expires after the old one. And that's the way we basically verify that even refreshed JSON Web Tokens are correct. And that's pretty much it for that. And let me just quickly run our npm test to verify we have running tests, because we actually cannot have breaking tests if we keep going like this. It just becomes like a snowball. It becomes harder and harder to fix if you don't fix them on time. So let's see. There we go. That works. Cool. Now let's move on. Let's create our user tests, which are going to be also quite similar. So let's add our new user test.js. So I really like how all of these concepts just build on top of each other. So it's kind of more of the same. So as usual, we import our boilerplate. So we import Mongoose, Chai, ChaiGDP, and Faker. We also initialize. So let's not forget to initialize our ChaiGDP plugin, as you can see right here. And then let's also initialize our testing structure. So it's going to look a bit like this. So here's our describe block. We also want to have our, let's close our describe block. So here is our describe block. Oh, quick question from Christopher. Would you like to ask the question right now?
Yeah, should that user test file be in the user folder, or should it be in the test folder?
Oh, good catch. Good catch. I was kind of excited there, as you can see. So yeah, you're absolutely correct. Good catch. I probably found out about that, and it would have taken me quite a while to figure out, because like, why isn't it running? That's a good catch. Great catch. So let's move on. So let's add our usual boilerplate. So we want, as usual, to be able to, before each test, we want to start our server, we want to stop our server, the usual boilerplate. So let's do that right now. So it looks a bit like this. So the before block looks the same. It's before, start the server, then after all the tests, stop the server. The after each also looks very similar. After each test, shut down the entire database, delete it from existence. And then before each, we do the same thing we did previously. We create a faker user, and then we basically create a test user. And that's it. We just want a fake test user that we can test against. So that's pretty much it as far as boilerplate for the before and each. Now let's just quickly add our faker function right about here. And let's also, with that in mind, we should be able to write our first test, which is basically should create a new user. So let's add that test right now. So let's add our test. How about here? Looks like a good spot. And well, we explained that. Let's start the debugger so we can see how this test runs and flows. So first, we basically, because we already have a created user, in this scenario, we want to be able to create a new user. So here, I create a new user with faker. So, oh, I forgot to remove my old breakpoint. Let's continue with that. So, there we go. So basically, it creates a new user in our database. So I'm actually going to verify that. So it created Thomas Wendler with an email of frederick.frami. So I'm going to actually compare that to my users database, and you can see that one of these should be, there we go, there's Thomas Wendler. So it creates a new user, and then to verify your API works as expected, it checks that the status code is of type created, which is 201. So we check response, there's a 201. Then it verifies that it's a JSON. We can see that in fact it is of type application JSON. It does a few other tests, like expect that the response body is an object. It is an object. And then finally, we verify that the server responds with our actual user. So we verify that it includes things like ID, name, username, and email, and that they match the newly created user. If everything goes as expected, we should have a winning test, which if I let it play, we should see a success as well. So that's our user test. Pretty simple, right? And notice how after running these, as usual, if I try to fetch users, there's no users, because that's the way we coded it. We want our entire database to be wiped every single time we run our test. The original database, the one we actually use to test, it's intact. Like, notice how it still has the records we used during our last session. So yeah, that's a pretty cool way of running tests. And we're almost done. We basically have, you could say, the longest test to do, which is the actual nodes test. But I would say it's actually the easiest one, because we pretty much have the bulk of how tests work. So this is going to be more repetition. So let's do that right now. Let's add a new, let me close that so I don't make the same rookie mistake. So let's do node.test.js. As usual, let's add the boilerplate. So this is the boilerplate for this test. Now the biggest differences here is this time we actually import the user and the node model. The reason why we do this is because before you're able to basically create every test, you will need to first be able to log in, because remember, these endpoints are protected. Like if I open my node router, you can see that all of them have authenticated middleware. So you cannot access most of these unless you have an actual valid JSON Web Token. So we're going to be created a fake JSON Web Token, a fake user, and fake nodes. So that's why we need all of this entire, like it looks like a lot, but it's actually all necessary. So let's continue with our usual boilerplate. So let's add our describe block like so. It's nothing you aren't familiar with by now. So this will be our integration tests for /API/node. So let's add that in. And I might as well have my node router by my side in case I need it. So here's my node router. And we're going to be testing this router. So as usual, because it's a new test, we're going to need a few functions pre-prepared, like most importantly, our faker functions. I'm going to add them from the start this time around. And they're actually going to be a bit different. So we still have the faker user, but we also need a create faker node, so we can create fake nodes. Otherwise, you would have to type that in, but that's kind of boring. Let's just use fake data, right? And with that said, we can now add the boilerplate, like what to do before, after, and during all their tests. So let's add that in right about here. So let's just quickly walk through this. The before loop is nothing you haven't seen before. It's the start the server before this entire test file. The after all my tests, it shuts down the server, and then before each test, this one's kind of a long one. So I'll tell you why this is kind of a long one. But just before I do that, just quickly remind you that after each test, it's going to wipe the entire database. Now, let's just quickly review why before each is so long this time. So at the start, it does something we're already familiar with. It creates a new user. So we try to create a new user. And if it is successful, as you can see right here, if it is successful, it is saved into our test user global, which we can see right about here. So here's the test user global. And then if that's successful, we basically sign our JSON Web Token. So we sign a JSON Web Token, a fake one, by the way, which we will be using very shortly to actually access our endpoints. And then this is where it gets interesting. So we were able to create a user, but we don't have any nodes. We want to be able to test nodes. So to do that, I'm going to create an array called seed data. And then inside of this array, 10 times, I'm going to create a new node. I'm going to attach to the newly created nodes.user parameter the created user ID. This is what allows nodes to be attached to a user. So if you look, for example, my actual real database, you can see that nodes like this one, in the user, they have an object ID, and this object ID matches one of my users. So it's the exact same object ID. So that's what ties them together. So when I create my seed data, I need to make sure all my nodes belong to this user I created. And once that's completed, I am now able to add a new node to my seed data. And then once I'm ready and I have 10 objects of nodes, I then just push them into my database using node.insertMany. Then if I get an error, I just throw an error, but that's about it. Basically, the one thing I really want to highlight before I continue is you can also create new nodes by literally just accessing the node router and adding new nodes via the endpoint, like create new node. But I found this really tedious. Like you have to authenticate, you have to do post. It's a lot more. Well, you having the node, the MongoDB model, you can actually inject them directly, which is just makes this so much easier and more straight to the point. So yeah, with that said, we should now have the ability to finally run tests. So let's add quick comment. So does that create 10 nodes for one user? You're absolutely correct. That will create 10 nodes tied to that user, but we are actually going to see that in action. So let's add our first test. And as usual, let's, wrong clipboard. Let me make sure I got this correct. So let's add it. How about here? Yeah. And let's also add a debugger breakpoint. Let's make sure we delete. Yeah, there's no more debugger breakpoints. Let's run our tests. Now, oops, I seem to have added it in the wrong place. Oh boy, that's not going to run as expected, but let's wait and see. Let's hope for the best. I think maybe it did that. It did attach them in time. There we go. So nice. So this is what our tests are going to look like. So this time it's going to test the get API/node endpoint. So the first test is expect the usual, check that it's a JSON, check that the body is an array. So if I just iterate over this, I can check that response.body is in fact an array with 10 nodes as we created previously. And then it checks that the body does include at least more than one node. And then, because I want to make sure the nodes are real, I'm going to extract the first node from my body response. And then this node I extract from it, I'm going to check that it has a valid node. So it has to have things like user, title, and content. And we can see that in fact it does have user, title, and content. And you can see all their fake data. So a really cool fake title and a really cool fake content, which makes no sense whatsoever, but that's not the point. And also I like to do this test. So here I am making sure that the node has a user object that matches the created user we made at the start. So basically, we check that the node's user property has the name, email, and username, and we also check that they match the ID, username, and email of the original test user we created. This one, remember, we created that at the very start of our all tests. So here we're doing test user equals create faker user, and this is a global for all our tests. So that's the way we verify that these nodes actually belong to the user we created originally. And that's pretty much it. This test should finish without a hitch, and we're pretty much done for the should return user nodes. Now let's add a new test, which is going to be very similar to that one, and it's let's test if we can actually return just one node. So for this one, we do a bit differently. So instead of creating a node, we just do node.find to query all the nodes and just find one of our nodes. Then, using our nodes array, which, you know what, I should be debugging this. Let me just start the debugging session as well. Okay, let's start the debugger. And the usual test, we expect that nodes is in fact an array. So we extract one of the nodes, and then we basically take one of it out and save it into a variable called new node. So let me show you how that looks. So here's my nodes array. I'm going to extract the first one, and that's what I like to do here. So I extract the first one into a variable called found node, and then what I'm actually going to do is actually test the endpoint. So I'm going to do get/API/node, and then I'm going to inject my found node's ID, which this, by the way, should match the one we have on our database. This is why you, when testing, especially these things that rely on database, you should always have MongoLab open and handy, so you can just verify that this all indeed exists. So our found node has a, let's see, for example, title of quasi delenti et rerum, and let's verify our nodes. And there is, nope, wrong database. There we go, here's nodes. So that would be our first node. There it is, quasi delenti et rerum. So that's the node we're testing right now. So we basically query or get endpoint for the found node. Super important because this is a protected endpoint. We attach the JSON Web Token to be able to fetch nodes. So we attach the JSON Web Token to show our endpoint. We're authenticated. Now to get to this function, I'm going to add a new breakpoint on line 143 and then just click play. So it skips me like almost like going ahead of time. And then we basically check that the return node matches the original node we had. So the response.body should be the node we tried to search for originally. And you can see that it in fact matches the original found node. So that's pretty much it. That's the testing of one specific node. And you can see that that passes as well. Now let's continue with the, let's do the updating of a specific node. So I believe it's this one. So let me just add that one right about now. Give me 1 sec. So this is the one to update a node. Now, to be able to update the node, we need to do a few different things. So first, we need to make sure we basically create a new node data that we're going to use it to update an old node. So in this scenario, what's going to happen is we're going to fetch, again, one of our nodes in our database, and we're going to try to update it with new node data. So we do what we did previously, that we basically fetched just all the nodes in our database belonging on the database, and then we extract one of them into a variable called node to update, as you can see here. So here's my nodes array with 10 items. Then I extract the first item in my nodes array, and I save that into a variable called node to update. Then I make an actual put request. Now remember, this should always match the server you actually are testing. So if I look at my node router, you will see that my update endpoint is router.put, and it's the actual node ID. So this needs to match, super important. So I make a put request to update a node with the node to update ID. And then I also make sure I'm authorized, otherwise I'm going to get an error. So I make sure I'm authorized. And then finally, I make sure to send the new node data. So it's going to update our first node, which has the title of tempora omnis in et. So let's just verify that super quick. So here's our first node, tempora omnis in et. And that's going to be updated very soon to this new node data with a title of repudiandae quae set audio out. So it's going to be making that update. Let's just press play so it stops our new debugger statement. And then we check that the response has indeed a status of no content, which it gets responded when it was successful. Now, we could just wrap it up here and call it a day, but that's not what a good tester does. We need to make sure that it did update this in fact. So now, instead of just finishing here, I try to find the original node I updated by ID. So here's my node to update.id. So I search my database for it, and then I make sure that in fact it was updated by comparing it to my node to update object. And let's just verify that right here. So here's my node, and there's a title, repudiante quae z audio out at k. So definitely worked. And we can just verify that claim by querying the database. So here's the new data, and there it is. There's a new title, and notice how it's different from the old results. This is what we had previously, and this is the new one. So it worked. And we're almost done. We're almost done. It's our final test now, deletion. So we need to be able to test that we can delete nodes. So let's let this run as expected. Let's clear all our breakpoints, and let's add our final test before we move on to the automation stuff, which will be the easiest part of this by far. So let us add our final test, which is the should delete a specific node 8 point. node endpoint. So this one, basically the way it's going to work is somewhat like this. So let me just quickly, hang on a sec. I think I might have this incorrect. Give me one sec. That should be the delete endpoint. I think I might actually. Oh, never mind. I think I do have it. I guess. I don't know why. Okay, that's cool. So, very well. So it looks like I am actually sending erroneously this node data. So that's a mistake I will correct right now. I don't really need node data to delete a node. So there we go. That's pretty much it. So first things first, I basically find all my nodes as usual. So I fetch all my nodes because I want to delete one of them. But in order to delete one of them, I need the ID of one of them. So I'm going to fetch all my nodes. Then I'm going to extract one as usual. I pick the first one. So this time our victim is going to be our first node. So let's see what our first node is. Let's make sure until we get to this test, because remember, each test has its own database. So that's when we need to wait until it actually gets reached. Then we can finally open our nodes. And our victim here is going to be $uit eus $out m. So that's going to be the node that's going to be gone very soon. So we extract that first node. So here's a node to delete. So there's our $ut eus $. And we are going to try to delete it using the node to delete .id. So I do that. I make the delete request, and I make sure that I'm actually doing .set inside of it. So I do that to make sure that I am actually authenticated. I'm authorized to make this change. And then if this is expected, I add a new breakpoint on line 197 to run to it. And I then check that the response indeed has a status code of HTTP no content. Now this I can verify is in fact true by opening my node router's delete endpoint. So if I go to my delete endpoint, you can see that on success, I return a status code of no content. This is why it's actually recommended that you have your router, your testing side by side, so you can just compare them and make sure you're actually testing things correctly. So yeah, that looks like that's correct. Let me check my response. It has a status code of 204, and that matches my no content status code. So far we're good. And again, as usual, we could wrap it up here, but we're good testers. So we're going to make sure that it was in fact deleted. So I do a node, find by ID, and then I query the database to see if my node to delete's ID doesn't exist anymore inside of it. So I'm going to do that, add a breakpoint here, and then there's this really handy syntax that it checks if null is not a variable. So here we're checking expect node to not exist, which we can see is true. It doesn't exist. It returned null. And we can compare that by clicking on nodes, and you can see that we had 10 items before, now we have 9. And the first one is no longer $out m $. So it's out tatem kiskam. So yeah, that's pretty much it as far as testing goes. We now have fully functional test framework. I guess it is now time for Travis, yeah? So let's do that right now. Let's proceed to add this to Travis. So let us, first things first, let's add a basic Travis config file. Now, the way I like to do this is literally just following the actual instructions from Thinkful's material. So if I open it, it's on the unit 1 of server-side content. Let me fetch that really quick. So here's the server-side curriculum part. The instructions are relatively clear. It's just creating a travis.yaml file and adding that to your repository. So let's do that right now. So let's create a new travis.yaml file. Did I create it correctly? Oh, it's .travis.yaml. Great, good thing I caught that really early on. So yeah, let's add that in. And we also need to not forget that once you start testing MongoDB as well, you need to factor in that you need to configure your integration to also start MongoDB. So if you look at the MongoDB comment, yes, there is a method of initializing Travis. But I like to do it the old-fashioned way sometimes. I don't know. I guess it makes it easier to explain at times. So basically, you just need to make sure you indeed have your MongoDB integration set up with Travis. This is actually already documented in Travis's official documentation. So if you search for Travis, MongoDB, they actually explain how that actually works. So here you can see database setup and how to actually tell Travis that, hey, I have a database. Please make sure you have MongoDB running. So that explains in depth how that works and all the other different databases you can use. So having said that, you do specify the language to be Node.js. And this kind of redundant part, it's actually the version of Node you want to use. So in this scenario, I want to use the latest version of Node. So you just write Node to use the latest. And that's pretty much it. So let us add this and let's see if Travis actually detects this. So let's do git add. I forgot the MongoDB part. Let's add that in super quick. So where is it? Where are you? Where is it? There we go. There's services. Copy, paste, save, and get it all. Git commit, add unit testing and CI. Let's do a git push, and that should be pretty much it for the code side of things. Let's compare that to Travis before we move on to the Heroku part, because we also need to be able to deploy to Heroku. So let's do that right now. Let's go to our GitHub repository, which is this one. So here it is. If I refresh it, we should have a brand new commit. However, it doesn't look like that has Travis enabled. There's no Travis here. So if there was Travis, we would see an icon like a build is running. So let's check our Travis dashboard to see why we cannot actually access our repositories. So let me visit my settings so I can check my repositories and enable my actual just jotted testing. So that's off. That is weird. Let me just quickly rename this. Maybe that could be it. Testing 2. Let's just rename this to testing 2. This might be caused because I actually used this last session, so Travis I think hasn't forgotten about it. So I think that's what's happening. Let's go to repositories. Let's add a new repository for testing, just jotted testing 2, and we should hopefully see it somewhere here. So let's wait for that to sync. It takes a bit of a while. In the meantime, let me see if I can't find it. It's Travis testing 2. There we go. So that's synced up. Maybe it's on page 2. Nope. Maybe page 1. There we go. There it is. It's off. Let's enable that. And that's Travis. That's Travis enabled. So now with Travis enabled, we need to make a push to our test, to our repository. So let's just, let's create a readme.md file. And let's just add a message saying, hello. So hello, this is a test. And let's save that. Let's add it. This time I'm going to do it from VS Code. So you can actually use VS Code's Git manager to add files to the staging area and even commit them from here. So add it, readme.md, and press the arrow. You can see that now it says that I am one commit ahead of master. So I'm just click on this to push changes automatically for me. And come on. It's taking a bit longer than expected. There we go. That's loaded. So let's just make sure that's in fact working by going to our just jotted repository, refreshing. We should see 3 commits. And this time, oh look, there's the Travis build. We now have a Travis indicator on GitHub. We can actually click on that and it will take us to the actually running build on Travis. So that's really handy. We can see that our tests are actually running. So this is just starting. So we have to wait for the test to actually start running before we can actually see it. So let's have that. This is really cool. You can actually see your test run live and what's happening in real time. That's really cool. I really like this thing about Travis. And while that is happening, I might as well just quickly open the Heroku integration, which I think we have right about here. So I might be able to do my login and integrate with Heroku. So let's do that right now. Let us do our travis.login to make sure we are actually logged into Travis. Oh boy, that's going to be quite a bit of a blocker. Okay, that's going to be a very big blocker. I think I made some changes on my work machine, so I don't think I have Travis configured correctly. It's not even installed. So we might have to skip this part, but I will still guide you through it. So I might not be able to do it, but it's actually kind of simple. So you're going to be doing Travis login. This is something I always do for sanity reasons. So when you've been in the industry as long as me, you want to make sure nothing can go wrong. Even if you have to log in every single time you create a new build. Even though this is saved in cache, I like to do it anyways, just to make sure I'm actually logged in. The second thing is doing the Travis setup Heroku. Now, here is a really, really big warning. I've had quite a few of my students, and I've seen a lot of students have problem with this command. And it seems that the cause is git bash. So this nice and colors you can see here, this is git bash running. So in Windows, we have basically the command prompt, which is the standard pretty ugly terminal you can see right here. And we have git bash, which is this newer terminal that Git installs that looks a bit like this. And it's cooler to use because it has colors, it has more commands. However, Travis setup Heroku seems to crash on it. And I've had when it crashed on me the first time, I had no idea what was wrong because this is not documented in many places. So what I'm going to recommend, if you want to basically set up a Heroku via Travis, what you want to do is add this, instead of doing this, just search for Travis setup Heroku, and you want to look up the documentation, and this teaches you the commands you can run. I like to run the alternative they suggest, this one. So I really like to run this command instead of the Travis setup Heroku. However, if you're on macOS or Unix, you're probably fine running Travis setup Heroku. So that's a huge disclaimer / warning for Windows users using git bash. So with that in mind, that should allow you to automatically push changes to Heroku. So you add that, then you add heroku.create, which creates your Heroku app. And you just end up configuring your Heroku app. If you have questions, I really like relying on Travis's Heroku documentation. It's fantastic. I really like how well they document basically everything you can add, especially this part. This is something I see a lot of students having trouble with. They don't like Heroku's name for their apps. They have really cool names, but they're kind of funky at times, like Weird Octopus Red or Cool Core Yellow or something like that. So if you want to rename your app, you need to add this extra field to tell Travis that it's pushing to a custom named Heroku app. So that's really important right here. So make sure you add that and just give this a read. It doesn't you no harm to read this and make sure you actually know what you're adding to your Travis config file. And once that's set up, you should automatically see your. So we went back and you can see that our original build. It's this one. Yeah, that's the one. So it ran as expected. So here it is. It was successful as expected. However, if you add the Heroku integration, it's going to look a bit like this one. So this is the one that I already have set up. So it runs all your tests, and then if you added Heroku, it's going to run the Heroku integration, like installing deploy dependencies, preparing to deploy, deploying application, which is literally just pushing this entire thingy to Heroku. And that's pretty much it. Now, this doesn't mean you're done. Heroku still has some things you need to set up, which I'm just going to quickly cover, because I think there is one or two students here that are having trouble setting up their Heroku installations. So if you're having trouble setting it up, you need to make sure of two things. So thing number one, you need to make sure is log into your Heroku panel. So let's log in right here. Come on. Of course, I need to log in. So let me quickly log in, because I do not remember my passwords. I'm very forgetful, as you can see. And there we go. There's my password. And you need to make sure you have your two environment variables set up correctly. So thing number one you need to make sure you have is your database URL. So if you look at my Just Jot It application, if you look at my settings and go to the config bars, I have two things. I have my GWT secret, which is a not very secret string, super secret key 123. So it's very important that you have this. and then you have to have a valid Mongo URL. Now, this is something I've seen some students struggle with, so I'm just quickly going to show you how to generate this. Now, instead of running of my local MongoDB installation, you want to be using an mlab installation. And to do that, all you have to do is go to mlab.com. You log into your account, create one if you don't have one. mlab is fantastic. So let's go to log in, and let's visit our list of databases, like so. And we can see that I have already a few databases. So here's my just chatted database. So in order to connect to it, all you have to do is just create a new database. So basically, the creation of the database is incredibly simple. I don't think you can actually mess that up, seriously. Like, you just create new and select all the defaults. And select all the options that are free, because they do have paid database tiers. So you open your newly created database, and once you're in it, you're going to get a lot of really handy information, like this one. To connect via a driver using the MongoDB URI, you use this URL. So you're going to copy this and paste it in Heroku. So that's what's actually here. Now, however, you also want to make sure you create a user. This is something that I forgot when I was first learning about MongoDB. Don't make the same mistake as me. So make sure to click on add database user. Make sure you create a new database username and password. And then that database username and password, you want to copy paste it here without the opening and closing greater than less than, and replace the password here. And you're pretty much set. And that's pretty much what my configuration looks like. So you can see that I have MongoDB, S Garcia username, S Garcia 1 password, and then my entire URL, which is basically just this thing copy pasted. And with that set up, that is pretty much it. So yeah, I guess that's kind of went overboard 5 minutes. So sorry about that. It's a lot. It's really a lot to cover in just 1 hour, but it's the best I could do. I don't think if I split it up, I think a lot of students wouldn't really like attending 2 sessions just for unit testing. So that's why I ended up doing that decision. So yeah, my apologies for not being able to implement Heroku into my database with Heroku config. But yeah, I definitely need to fix that by next session. So yeah, let's do 5-10 minutes for questions, comments, concerns, thoughts, whatever. I think one of you at least did mention that you had something you would like to ask. So let's go. What would you guys like to ask?
So what part of your code makes it so that your collection in MLab is the same? Because I remember I had that difficulty setting up my collections in MLab.
Oh, you want to have the same collections on MLab as in your computer?
Kind of. It's just like, well, let me look at MLab real.
Sure. Yeah, I haven't heard about that. Oh, let me stop the recording. I almost forgot.